So my dear friends, we are now going to start actually a new series of lectures that we have named as Concept Talk. Basically, in my around 25 to 30 years of teaching experience, I have noticed that even though students are able to solve the questions, they are still poor in the fundamental concepts of math, basic concepts. For example, if you ask one student that, okay, two angles of triangle are 60 degree, 70 degree, find the third angle, they will quickly answer. But if you ask them, what is an angle? Then they will start thinking. For example, one more example, you ask them 5 over 7, is it a rational number or irrational? Okay, they can answer. But you ask them, what is rational number? They again start thinking. So basically, if you see, no building can be made, no very strong building, very high building cannot be made without a stronger plinth. So this series will basically be aimed at making that plinth of the building. It will not only be useful for school-going children, it will be equally useful for college-going or anybody, a common man, interested in understanding the concepts of mathematics in a simple language. And we will try to at least put 2 concept talks every week, ranging the various dimensions of mathematics or various areas, maybe arithmetic, algebra, geometry, or even from sciences. So I hope you will enjoy. So let us start with our first concept talk today. And we will be talking about very, very basic thing, that is real numbers. Now, what is a real number? See, very common term we come across. But what is a real number? That has to be understood well. If we go just by definition, what the real number means. See, all of you have studied about the number line. Since our perhaps grade 3 or 4, we are studying number line. That number line, what that number line means, it just represents real numbers. All the real numbers, they are put on the number line in the increasing order from left to right. 0 being the central point. So all the numbers which exist on number line, all the numbers which exist on number line, they are real numbers. Like all these 0, 1, 2, 3, -1, -2, these integers, they are real numbers. Even all those numbers which lie between them, for example, between 0 and 1, you see there is a 0.5. Between 1 and 2, you may see it is 3 over 2 or 1.5. So all these are real numbers. Even pi is also a real number. And you can locate these real numbers on the number line. So fundamentally, any number which exists on the number line, this real number line, which can be plotted here, which exists, which you can say that it's okay here, that is a real number. Now that's a separate issue that you have to study what different kind of real numbers are. So if we study what kind of real numbers are, for that, all the real numbers can basically be classified into 2 categories, that is rational and irrational. But in order to understand what these things are, let us understand in a different way. Let's understand a few more basic terms, and then we will come on the point what the real numbers are. Okay. So, do you know what the integers are. So integers means full numbers. That may be 0, it may be 1, it may be 2, it may be 3, it may be -1, it may be -2. You know about them, they exist on the number line. All these are integers. Now these integers can further be of different types, like these integers, which are from 1, 2, 3, 4 and so on. These are also called natural numbers. These are called natural numbers. If I consider 0 also, that means 0, 1, 2, 3, 4, these are called whole numbers. Other name for natural numbers is positive integers. While on this side you look for negative integers. Zero is the only integer. If you look, the 0 is the only integer which is neither positive nor negative. So integers are the simple issue, and that is not that much confusing. Now other point here is regarding rational numbers, fractional numbers. So what are fractional numbers? Simply something which is not full. Means which is not an integer, something lying between integers. But look carefully. Within fractional numbers, you may write it as a numerator over a denominator, or you write the same number as decimal. You write the same number as decimal too. Like 1 over 5. This is a fraction. You can write this 1 over 5 as 0.2. So all these are fractional numbers. And if we go to the basic thing, these integers and fractional numbers, if you take them together, actually they constitute rational numbers. They constitute rational numbers. That means all integers are rational, all fractional numbers are rational. So question automatically generates, what is a rational number? How do we define it? So look carefully. We studied integers, we studied fractional numbers. Both of them are basically rational numbers. So if you say 2, it's an integer, it's a rational number. It's a positive integer. 0, it's an integer, still it's a rational number. If you take -3, it's a negative integer. This is also a rational number. If you take 1 over 2, half, or 0.5, that's also a rational number, that's a fractional number. So all these numbers, all the gametes of these numbers which are commonly used in our daily life, they are rational numbers. So how is it defined? If you look carefully, a rational number is defined as a real number. Any real number that can be expressed in the form of P over Q. That can be expressed in the form of P over Q. What the P and Q mean? P and Q are integers and Q not equal to 0. Try to understand this carefully. It means if there is any number and you can somehow express it as integer divided by integer. For example, you have a number 2. Can you write it in the form of integer divided by integer? Yes, you can write it as 2 over 1. What the other condition is? P and Q must be integers. 2 is an integer. 1 is an integer. Other condition is this Q must not be 0. Means denominator should not be 0. Is it 0? No. So this 2 is a rational number. So any number which you can write as numerator divided by denominator and denominator should not be 0, that is a rational number. But if you can't express a number like this, that is not rational. Let's take a few more examples. So for example, you have a number 1.5. Now, can you write it in this form P over Q? Look, can't I write that 1.5 as 3 over 2? It's 1.5. So this is 3 is integer, 2 is integer, and this 2 is not 0, 2. Therefore, it is also a rational number. For example, I say minus 2 over 3. Is it rational? Look carefully, I can write it as minus 2 over 3. Is minus 2 an integer? Yes, it's a negative integer, but still integer. 3, it's also integer. Is it 0? No. So if you can write any number as numerator over denominator, where denominator should not be 0, that is called a rational number. So for example, is 22 over 7, is it a rational number? Yes, because 22 is an integer, 7 is an integer, but this 7 is not 0, so it is also a rational number. So any number, if you look carefully, whichever the fractions you see, for example, you say 1.125, is it rational number? Answer is yes. Why? Because after all, you can write it as 1125 divided by 1000. 1125, this is an integer. 1000, this is also an integer, but this 1000 is not 0. Only condition is your numerator should be integer, denominator should be integer, but denominator should not be 0. If you can express, if you can write a number like this, it is definitely a rational number. And if any real number cannot be written like this, it's not rational. So that clears perhaps this definition. One example, for example, if I say you root 2, is it rational? Can you write it in the form of numerator over denominator, where both numerator and denominator are integers? Answer is no, you can't. So that's why this is not a rational number. So that's the only way how do we define the rational numbers. Now these rational numbers we have started. There's another way to look at these rational numbers if you want to see. You can classify all the rational numbers into 3 categories. All the rational numbers, they come into 3 categories. That's another way to say. One are all integers. You know, all integers are rational numbers. It may be -2, it may be 5, it may be 0, it may be anything. All these integers are rational numbers because all of them can be written in the form of P over Q, numerator over denominator, where denominator is not 0, both numerator and denominator are integers. So they are all integers are rational number. Second thing, second category comes of terminating decimals. Terminating. What does terminating mean? Terminate means somewhere ending. That means those decimals which end somewhere. All those are rational numbers. For example, you take 1 over 2. If you convert it to decimal, it comes out to be 0.5 and further division, note nothing else here. It ends here. For example, you take 1 over 4, so it is 0.25, it ends here. You take 1 over 8, it is 0.125 and it ends here. It doesn't continue further. So all these terminating decimals are basically rational numbers. So what we studied right now, 2 categories we did. One are integers, other are terminating decimals. All terminating decimals. But there are certain numbers which are not terminating decimals, but still they are rational. For example, you take 1 over 3. If you convert it to decimal, will it be terminating? No. You continue to divide 0.3333, so on. It will continue forever. It is never going to end. You divide 1 by 3, so it is 0. It is here 0.00. You divide. You continuously divide, and this 1 will continue to be as a remainder. It's never going to end. So these are non-terminating decimals. So it means, but still, if you look at the basic definition of rational number, 1 over 3 is a rational number because 1 is integer, 3 is integer, and this 3 is not 0. So it is also rational. It means these non-terminating decimals are also rational. But not all non-terminating decimals are rational. Within non-terminating decimals, there will be two categories. Some will be rational, some will be irrational too. We'll come on that. So here, so if you look carefully in these non-terminating ones, here 3333, that means you can write this number as 0.3 bar. That means there is some digit, one or more than one digits are repeating. Same digits or group of digits coming together. So for example, one group may be, for example, you divide 1 by 7. What will that be? It will be 0.142857142857142857 and so on. If you look carefully, these 6 digits 142857142857, it is repeating again and again. It's never going to end. But still they are repeating. So these non-terminating but repeating decimals, they are also rational numbers, because you see carefully, we can write them in the form of integer over integer, and in your class 9 you will study the method also, how to convert this form to this form, and we will study it in the lecture of your chapter 1 of class 9th, how to convert them. But right now you know. So all these rational numbers basically can be categorized into these three categories. Either they are integers, or they are terminating decimals, or they are non-terminating but repeating. So what is left? Only which are non-terminating and non-repeating. Nothing else is left from your known numbers. And that is what the category is regarding irrational numbers. So those are the numbers which are real, but they are not the rational one. For example, I write a number 2.142812481128. I write anything. So neither it is terminating nor it is repeating. They are irrational numbers. Like you calculate square root of 2. What is square root of 2? It's 1.4142, so on. It's never going to end, and it's not going to repeat even. And you cannot express it in the form P or Q. So these are irrational numbers. For all practical purposes, the square roots, or roots simply you can say, square roots of imperfect squares, which are not perfect one, they are all irrational numbers. Root 2, root 3, but root 4 is not irrational, because root 4 is 2. That's a rational number. But if you take root 4.1, this is an irrational number. So basic identification is any number, if you convert it to decimal form, if it never terminates, if it doesn't repeat even, then it is an irrational number. And most commonly used irrational numbers are the square roots, though they can be higher ordered roots too, cube root, fourth root, and so on. Only condition is that this, after solving the root sign, this should convert in such a manner, not to an integer. So What's in total? If we look at our whole of the concept of today, we know there are integers. These integers may be positive integers or maybe negative integers or maybe zero. Positive integers are natural numbers. Zero and positive integers together are whole numbers. Then there are fractional numbers. Together they constitute rational numbers. Rational numbers consist of all integers. In fractions they consist of terminating and repeating ones. And then terminating means non-terminating and non-repeating. They come under irrational. That's what we studied right now. And together they constitute real numbers. It means what the real numbers are. All these categories. And they can be plotted on the number line. Even we can exactly locate where a real number exactly exists on the number line. There are ways to denote it. There are ways to find it. There are ways to point it out. Is that clear? So that is about our real numbers, and this slide further explains the relationship between all the type of real numbers. All these real numbers are two types, rational and irrational. Irrational, all those which are non-terminating, non-repeating decimals, and all left ones are rational. Even your pi is an irrational number. Because you have studied 22/7 or 3.14 as pi, actually these are not the exact values of pi. Because if you look carefully, these look like rational numbers. They are not irrational. But they are not correct values of pi. They are approximations of pi for your normal use. Real pi is 3.14159, so on. It continues. It's a non-terminating, non-repeating decimal. So even E, that also comes an irrational number. You will study in later classes. With irrational numbers, they are in, you can say, all fractions, then integers. Within integers, all whole numbers, negative integers, and within whole numbers, zero and positive integers, which are natural numbers. All of these are the real numbers. Correct? So I hope you have enjoyed it. But now question comes, all these are real numbers. Is there any other number left? Do you know any other number in your experience that, okay, this is the number I know, but it's not real? Answer is, it will not be in your experience. And we will have some other day to talk about those numbers which are called imaginary numbers. The numbers which don't come into your experience, but still in mathematics they exist, they have their own importance and they are needed. But that's altogether a separate issue. I hope you might have enjoyed this. Try to focus on the concepts, because our high-rise building can be made only on the strong foundations, only on the strong plinth. And it is just starting of that. So I expect that you might have enjoyed it. And please, if you like it, then like it, subscribe it, and share with your friends and other people whose kids or those people are interested in studying mathematics to the very basic level. Soon, along with this concept series, more videos are coming for the syllabus of class 9, 10, 11 and 12. That's all for today. Thank you to all of you for watching.